Welcome back to the book series of The Calculus of Friendship by Steven Strogatz. In this episode, we'll be looking into the fifth chapter where Steve discusses about the shift. Steve has almost compressed this chapter covering about a decade, that is from 1980 to 1989, but he says he had very little exchanges between himself and his teacher, Geoffrey. That is, he says that he has only about hardly 3 letters in his folder. The first letter dated December 16th, 1980 is where he started taking a shift in the content of his letter to his teacher Geoff. That is, this was the first time Steve expressed his gratitude, and also he has opened up about his ideas on his future linear trajectory, like doing a PhD, getting married and be a happy professor thereafter. And this was a major gear change for Steve, putting all these words to his teacher. The second letter dated September 21st, 1981, Steve mentions about his graduation with an AB in math from Princeton University, and about his thesis, which was on topology and differential geometry applied to biochemistry, and about his first paper in the Proceedings of National Academy of Sciences, and also that he received a Marshall Scholarship to do his master's. And he adds that he wants to do his PhD in math either at Harvard or Berkeley. But quickly he turns to his own self, that is back to writing about a problem deriving the nth term for Fibonacci sequence using shift operator, which we will discuss in a minute. And the last and the third letter for this entire period was dated September 2nd, 1985. But Steve was not so sure if the letter was way before he visited his teacher or quite shortly before he visiting sometime during the end of his studies in graduate school. And also it appears that Steve might have missed some of his letter correspondences as well. The major shift is that Steve started addressing his teacher as just Geoff, meaning he was taking a complete transition from being a teacher to just as a friend. That was a major shift for Steve. Now back to the problem of Fibonacci sequence, which is considered as a shining star of the vast array of sequences. We knew the Fibonacci sequence goes like this: 0, 1, 1, 2, 3, 5, 8, 13, 21. That is, the first 3 numbers are 0, 1 and 1. Sum of the previous 2 numbers. So it is, the fourth number is 2 is 1 plus 1, and 1 plus 2 is 3, and 2 plus 3 is 5, and 3 plus 5 is 8, and so on. So if we write the sequence as AO, A1, A2, A3, A4, A5, A6, A7, etc., and the initial condition is AO is 0 and A1 and A2 both are 1. And the sequence could be written as AN plus 2 to be the sum of AN plus 1 plus AN. And if we rewrite this equation, we have AN plus 2 minus AN plus 1 minus AN to be 0. And we know that the shift left operator L is given by the rule L of xn to be xn plus 1. So this sequence goes like this: x2, x3, x4 and so on, which is just the original sequence shifted one step backward. Hence it is known as shift left operator. So accordingly here we have an plus 1 to be L of an, and an plus 2 to be L of an plus 1, which if we rewrite, it could be written as L of an, which is L square an. So if we substitute this in equation 3, we have L square an minus L of an minus an to be 0, which results in L square minus L minus 1 into an to be 0. So if we focus on this L square minus L minus 1 part, then we have the solution to be half of 1 plus or minus square root of 5. And the general solution for the equation 4 turns out to be A m1 power n plus B m2 power n, which is an. So now in order to arrive at the coefficients, if we use the initial condition a0 to be 0, we have a m1 power 0 plus b m2 power 0, which is equal to 0, which results in a to be equal to minus b. And if we use a1 to be 1, then we have a into 1 plus square root of 5 the whole divided by 2 minus, instead of b it is a here, a into 1 minus square root of 5 the whole divided by 2 is equal to 1. So rearranging, we arrive at a is equal to 1 by square root of 5. And substituting this in the original equation, we have an to be 1 by square root of 5 into 1 plus square root of 5 divided by 2 the whole power n minus 1 minus square root of 5 divided by 2 the whole power n. This formula was what Joff keeps mentioning to his students in his classes, as one of his students, Williams, responded with the very same equation in order to arrive at the nth term of the Fibonacci sequence. What a brilliant student, and what a great teacher who talks about a student all the time so proudly. Now, well, one might wonder the usage of this sequence or numbers. And if you look at the history, it was actually popularized by the rabbit problem, and have to say that this problem is found in the book Fibonacci, inspired a lot of mathematicians. And let's see how the problem goes. It says, how many pairs of rabbits will be produced in a year beginning with a single pair? If in every month each pair bears a new pair which becomes productive from the second month on, and assuming that rabbits are immortal. This celebrated problem, when expressed mathematically, will result in the equation 3 as we just discussed, which is nothing but an plus 2 to be an plus 1 plus an, giving rise to the Fibonacci sequence as shown here. There are a number of such occurrences of these Fibonacci numbers, like the genealogy of bees, which is very much similar to the rabbit problem, the field of optics, where the incident ray gets reflected internally before emerging, and the number of emerging beams for n internal reflections is equal to a Fibonacci number. And one more example could be a staircase with n stairs, where one can take either one step at a time or 2 steps at a time to climb the stairs. So the different ways of climbing the stairs take the Fibonacci sequence. So actually these Fibonacci numbers are famous for possessing wonderful and amazing properties, like, as we all know, ratio of Fibonacci numbers converge to golden mean. And the man behind all these is an Italian mathematician, Leonardo da Vinci, who was born in Pisa around 1175 AD. And he is commonly known as Fibonacci, which is a shortened form of Filius Bonaccio. And since his father was employed in the north coast of Africa, he was taught the Arabic system of numbers, and in the early 13th century, when he returned to Italy, he published the book Fibonacci, that is Book of the Abacus, in 1202. And this book introduced the Arabic system of numbers to Europe and is responsible for Fibonacci's reputation as the most accomplished mathematician of the Middle Ages. Let's keep exploring and enjoying the beauty behind the Fibonacci number wherever we come across. Thanks for listening, and see you in yet another mathematical concept from this book. Thank you.